Hello, welcome back to our Databricks journey. And in today's video, we're gonna talk about how to ingest raw data from ADLS Gen2 into Unity Catalog. We have a challenge. SecurePay, it's a fintech company that struggles with fragmented financial data. The data is scattered across storage, CSVs, and parquets, sits in raw data containers with no governance, lineage, or fraud detection capabilities. When we think about ADLS Gen2, we can use them in two ways because they could be storing our raw data files. This means that the Parquet, CSVs, JSON, text files, binary files are going to be stored in this ADLS Gen2. This is going to be like raw data with no transformations, with no governance, with no lineage. And the second way that we can use the storage accounts and containers is to centralize our data in catalogs. This is going to help us for discovery and governance. So in order to use this ADLS Gen2, we're going to require like two components, storage credentials and external locations. The storage credentials are going to be used to authenticate to cloud storage using a managed identity. This is going to act as a security bridge between Databricks and Azure storage. And the external location, it's going to map a specific cloud storage path to Unity Catalog. This is going to define what Databricks can access and govern. So the first step that we're going to take is to create an access connector within Azure. This is going to enable the system assigned managed entity, and this is what is going to let us authenticate to the ADLS Gen2. In order to do this, we can go to the Azure portal. I'm going to use this one. Look in the search bar as access connector for Azure Databricks. We can click here and create. We need to select a resource group. I'm going to use this one. And now we need to select a name. Once you choose a name, we click Next, Review and Create. And we can click and create. Our access connector has been created. We can go to the resource group. And now we can see in our resource group that we have the Databricks access connector. The step 2, it's about configuring the storage and containers on Azure. Let's take a look how we can achieve this. We can come back into the Azure portal. We can type in the search bar, storage accounts. Over here, we can click on create. Let's type in a storage account name. Then let's choose here Azure Blob Gen2. We can select default. Now, this is a very important step. We need to enable the hierarchical namespace. Once we do that, we can click next. Let's click next. On networking, by now, we're gonna leave the public network access enabled, but this is something we're gonna change later on. So let's click next. We can use default settings. Now let's make sure that we're using storage Gen2 and the hierarchical namespace is enabled. And let's click on create. Our resource has been created. Now we're gonna create some containers. My first container is gonna be called raw data. Click on create. And the second container, it's gonna be called SecurePay storage. Now that the two containers has been created, now I will create some folders under raw data. I'm gonna add a directory. I'm gonna name it as landing zone. And over here, I'm going to add some directories that represent the tables we're going to ingest. First table, it's gonna be called cards. Click save. Second table, it's gonna be called transactions. Third table, it's gonna be called users. Third table, it's gonna be called facts. Within those directories, we're gonna create 3 more folders. one for incoming data, and 2 more for schema evolution and incremental ingestion. That is going to be called checkpoints. Within those directories, we're going to create 3 more folders. One for schema evolution, another one for incremental ingestion, and the last one for incoming data. This folder structure that we have over here is optional, but we truly recommend it. So if you have the opportunity to organize your folders, please go ahead. We're going to repeat this for the other folders. So I'm going to pause the video and I'll come back in a few seconds. We are back. We created the structure for all of our folders, and we added some data in the incoming folder in each of them. Now we're going back into the containers, and we're going to create another directory in the secure page storage. This is going to be called Databricks Unity Catalog. It's a best practice to do not use the root storage as an external location, so we're going to create this folder. And now we're going to set up the access control. So let's click here and add role assignment. Let's filter by using a storage. Let's scroll down and select a storage blob data contributor. Click next. Click on manage identity. Select members. Access connector for Azure Databricks. Select the access connector that we created in the previous step. Click and select. Then click review and assign. Wait for a couple of minutes. The role assignment has been added into the storage account. By adding the managed identity as a storage blob data contributor, we're going to be able to handle the data within the storage accounts and containers. Now that we configured the ADLS GEN2, we can go to the next step and create a storage credential within Databricks. We can go to the workspace. We can click on Catalog. We can click on External Data. Click on Credentials. And we can click on Create Credential. We can go to the Azure portal. We can click on Access Connector for Azure Databricks. Click in the name of the access connector and copy the resource ID. Go back to the Databricks workspace. Paste the access connector. Let's set up a credential name. And click on Create. Let's add some permissions. Let's click on Grant. Let's use a group that can manage this access connector. We're going to use the Metastore admin ESDOS group. And on this one, I'm going to let this to create external locations, create external tables, read files, and write files. On privileges, I'm going to provide all privileges to this group. And next step, we need to define the external location. This is going to be the bridge. We're going to use a path within the container of the storage account that is going to let us create the catalogs or read the files that are over there. In order to do this, we can go to the workspace. We can click on catalog, click on external data, click on create external location. In the external location section, we need to choose a name and write a path of the external location. This is something that you can do it like using abfss colon / container name storage account name, .dfs.core, .windows.net, and then the folder path. Then we need to choose the access connector, and let's click on create. Let's click here in test connection, and we can see that everything is right. Click on done. Now you can click here and browse, and you can see the different directories and data that we added previously. We need to repeat the same steps as we did for the raw data container. We are setting up a name, the URL, and the same storage credential because both containers are under the same storage account. Let's click on create. Now let's click on test connection. And here we have an empty ADLS Gen2 path. When we're working on Databricks, we have two types of compute, classic compute and serverless compute. And each of them will require their own private endpoints configuration to make sure we can reach the data safely. I'm going to show you how we can set up this. We can go to the Azure portal, go to the storage account, click on network. Now let's disable the public network access. Let's click here, click on proceed, click on save. Now that we have restricted our network access, we're going to add some private endpoints. I'm going to click on create private endpoint. Come to select the resource group. I'm going to set up a name for the private endpoint. This is going to be a private endpoint for the DFS that is going to make a connection on the classic Databricks compute. I need to choose the same region of our VNet. I'll click next. I'm going to select DFS. Click on virtual network. Select the subnet for private link that we have in our Azure. Select the subnet for the private link. This is a segment of subnet that I created within the Azure Databricks VNet. Click on DNS. Make sure that you have the resource group. Over here, we're going to integrate this with the private DNS zone. Let's click next. Click on review and create. And click on create. Our first private endpoint has been created. Now let's create our second private endpoint. Let's go to networking. Let's click here on private endpoints. Click on create private endpoints. Let's set up a name. Click next. Here we're going to choose blob. Click next. We need to select the same virtual network as our Databricks workspace is using. We select the private link subnet that we created. Let's click next. Next. Review and create. And click on create. Now the next step is to establish a connection within the Databricks serverless compute and the storage accounts. In order to do this, we need to go to the account console. So you can go to the workspace, click in the name of the workspace, and then click on manage account. Then click on security, click on network connectivity configurations, and click on add network connectivity configurations. Let's type a name. I'm going to call it the storage and CC. I'm going to use the same region as my workspace. I'm going to click on add. I'll click here. Now I'm going to type here in private endpoint rules. Click on add private endpoint rule. paste the resource ID, and type plot over here. Click on Add. The first private endpoint has been added. Let's add the second one. Let's paste the resource ID again. And now let's type DFS. Click on Add. Now you can see that both private endpoints has been added, but both of them shows as a pending connection status. In order to prove them, we need to go to the Azure portal. We need to find the storage account. Let's go to networking. Click on private endpoints. Check the two private endpoints that are marked as a pending in the connection state and click approve. Yes, all of them are approved. Once our private endpoints have been approved, here in the storage account page, we need to attach the NCC as part of the workspace. In order to do this, we can go into the account console on Databricks. You click on workspaces, you choose the name of the workspace, and then click on update workspace. Now you need to look for the network connectivity configuration, and we add the storage NCC that we created previously. Click on update. This is going to take around 15 minutes to apply all the changes within the workspace, and make sure that you restart your serverless before trying to read some data in this storage account. We're going to learn how to ingest some files using Autoloader. So Autoloader, it's a Databricks native feature that will incrementally process new files as they arrive in the cloud storage. And this also has features as schema inference when you ingest data, so you don't have to manually define every column and data type. And schema evolution, it's about changes in your data sources. Data can be modified, new columns can be added. So this is going to help you to add these new columns into your tables. How are we going to do this? First, we're going to define some table configurations. So over here, I'm creating a list and a dictionary that I can use to define like the name, the format of the sources that I'm going to ingest, the raw data path. This is the same ADLS GEN2 where we saved the data previously in the incoming folder. You can point to any path. This is just the way I organize it. Then we have the checkpoints. This is that is going to help us to save which files have been ingested or not. And the schema location is going to keep track of the different changes that we have done to the tables. I'm repeating the same thing for the cards, users, and transactions. They are all CSVs, but then on the table of facts, we have a different data type per cat. So this is the one that I'm going to change to make sure that we can process the new data. Once we have over here, I'm defining that I want to save the data I'm ingesting from this raw path into this catalog and a schema. So I'm basically creating a for where I use read stream and cloud files. Cloud files means autoloader. So this is going to help us to use the different capabilities like the incremental ingestion, schema evolution, and schema inference. Once I'm defined this, so I'm setting up the format, if it's a CSV or Parquet, I'm setting up the schema locations and the inference also. And I'm loading using the raw path that we have here. Once we have loaded the data, we can write the data. So I'm going to write it on a Delta format, select this checkpoint location. This is going to help me keep track on which files have been uploaded or not. What I'm going to do with the schema, I'm going to merge it. This is going to be trigger once. And here I'm specifying on which table within Unity Catalog I want to save it. And over here with this command, you can take a look on the data that has been added. Now we're gonna talk about the silver layer. This is when we're gonna enrich and make sure the data is gonna be clean, queryable, and join with other data sets. Just building a very simple and small code that is cleaning some of the data. So you see that here we're dropping duplicates and we're writing into the silver schema, filtering some data like missing IDs. And here you can see where this data is being saved. The silver trusted banking cards, and the data has been uploaded. You can also take a look in the left panel about the different tables that you have within Unity Catalog. Then I'm building the gold layer, where over here we're basically aggregating and summarizing the data. This usually is when you want to apply the star schema and dimensional modelly, and you're making sure that you have high data quality. Here I'm just building a very simple code that is doing a group by. This is a short demo about how you can ingest files from your ADLS Gen2 while making sure that you create your tables within Unity Catalog so you can get that unified governance on your data assets.